Multiplying radical expressions are handled much the same way that polynomials with more than one term are multiplied. In this first example, we'll use the distributive property to simplify this multiplication. We'll have square root of 2x times square root of 2x minus square root of 2x times the square root of 8. Here we have the same radicand. In other words, we have the square root of 2x, the quantity squared, which is a perfect square. The second term, when we multiply the radicands together, leaves us with 16x. Simplifying further, the square root of something squared is that something, so we have a 2x. Square root of 16x can be broken into square root of 16 times the square root of x using our product rule for square roots, and simplifying further results in a perfect square with our square root of 16 times the square root of x for our final solution to this multiplication. In the next problem, we have a binomial looking radical expression squared, which means we have square root of 5 plus 3 times the square root of 5 plus 3. Using FOIL, we'll simplify this multiplication. First terms of each binomial multiplied together result in square root of 5 times square root of 5. The outer terms will be a positive 3 times the square root of 5. Inner terms multiplied together is also a positive 3 times the square root of 5. And last terms, a positive 3 times a positive 3. Simplifying, we'll have the square root of 25, which is 5. Here we have similar terms. 3 square root of 5 plus another 3 square root of 5 makes 6 square root of 5. Since these have the same radical expression, we can combine them as like terms. And simplifying the multiplication, 3 times 3 is 9. This has one more step that we can simplify by combining like terms. The 9 and 5 combine to give us a 14 plus 6 times the square root of 5 for the product of this radical expression squared. This next example is also a two-term radical expression multiplied together. If you notice, the first and second terms are exactly the same, except the signs are opposite, and you can think of this as a minus b times a plus b, where we have conjugates, and we find that the middle terms cancel one another out and should see the same happen here. So using FOIL to simplify, we'll have first terms multiplied together, 4 square root of x times 4 square root of x. Outer terms, we have 5 times 4 square root of x. Inner terms, we have a negative 5 times 4 square root of x. And last terms multiplied together, a negative 5 times a positive 5. Simplifying, we'll multiply our integers together to give us 16. Square root of x times square root of x is square root of x squared, or x, relying on commutative property to simplify. Ignoring the addition and moving to multiplication following order of operations, we have 5 times 4 is 20 square root of x. Skip the subtraction, move to multiplication. We can replace 5 times 4 with 20 square root of x. Here, and again, moving to the last multiplication, we have a 25. Simplifying this further by combining like terms, just as indicated, we do have our middle terms being opposites and canceling one another out. 20 square root of x minus 20 square root of x are additive inverses and cancel, leaving 16x minus 25. This may not look like the difference of squares that we see in the standard form here, but it is a difference of squares, our results. If you take 4 squared of x and square it, it is 16x, and 5 squared is 25. This should be noted that when we have a radical expression in this form times its opposite, in other words, conjugate pairs multiplied together, our result no longer has a radical in it, and something that we'll use when we look at division of radicals.